Hey math kids, today we're going to be in section 2.8b, interpreting functions that arise in applications, and we're just going to go through some set definitions first. So n, script n, is the natural numbers, and that's the set containing 1, 2, 3, 4, etc. So they're called the natural numbers because it's the first numbers you come across when you're counting. Then we have whole numbers, and that's the set containing 0, 1, 2, 3, 4, etc. So it's the same as natural numbers, but we just put a 0 in there. Now, script z is called integers, and that's if we take the whole numbers and we also put in the negative version of the whole numbers. Okay, now Q is rational numbers, and rational numbers we can't write in the same notation, but it's the idea of having an integer divided by an integer. So those are z's, but the bottom integer can't be 0. So we see that as, we already had a discussion earlier in this class about this, but it's whole numbers, integers, fractions, repeating decimals, and terminating decimals. So if you want to talk more about that, you can definitely come to Math Lab, or you can watch one of the earlier videos that discusses it in more detail. And then we're also going to real numbers. Real numbers are almost every number that you've come across that isn't imaginary. Okay, imaginary or complex. So hopefully that was helpful to some degree. Now we're gonna go over some of the in-class problems. So I'm actually looking at number 5A, and it says Jason has created a function that will tell him his share of a waiter's tips in a tip jar based on the total amount. Okay, so we're supposed to state what the domain should be restricted to for the following functions, and then explain our reasoning. So I'll read that one more time. Jason has created a function that will tell him his share of the waiter's tips, so his share, in a tip jar based on the total amount. Okay, so really we just need to know what are we plugging into the function to get something out of it. Now since it's based on, I didn't mean to cross that out, based on, that's a good indicator that we're going to plug that in. So if we plug that in, we'll get how much he gets out of it. So since we're talking about domain, we really only care about the total. We care about what we're going to plug in. Okay, so just remember, domain are the x values, and so the x values for this, we need to think of the total in the tip jar. What kind of numbers could we get? Well, for example, we could have $105.32 in a tip jar. And so if we're thinking of this number and we go back to these number systems, we probably don't want to use natural, whole, or integers because they don't allow for decimals. But we also don't want to let just any rational, because we could have 1.666666, so on, repeating, and that's not going to show up in the tip jar. So we're going to kind of modify it. So we're going to say rationals rounded to 2 decimal places. But I would even argue to say positive rationals, because we're not going to have negative money in a tip jar. So we're going to say positive rationals rounded to 2 decimal places. Okay, let's try one more like this. Okay, it says a function that calculates the height of a ball. The height of a ball at a specific time. So, if we're calculating, that's going to be the output, and that's what we don't care about right now, because we only care about domain. So at a specific time. So now we have to make a case for time. Now, if we're doing this, we are probably going to be thinking in at least seconds, if not fractions of a second. Once again, negative's not going to make sense. I think we can make a case that we can look at like pieces of a second. And so we're actually going to have a similar thing. Positive rationals that, now we don't have to round though if we don't want to, because we can take it out however far we want. In a practical case, we're going to have to pick something, but I think the main idea that I want to get across here is just positive rationals. Now you can say rounded to 10 decimal places, 5 decimal places, 1 decimal place, whatever you want, and then just make a reason, on your paper, give a reason why you rounded to that specific decimal place. But this is the key that we need. Okay. So let's talk about just like a practical domain now when dealing with a graph. So let's say we have this graph. Some guy's throwing a brick off his balcony. Balcony is 20 feet tall. And then this lands and hits at 1, 2, 3, 4, 5, 6. Now this is seconds, so that was threw it pretty high actually. But or gravity doesn't work, right? But so this is time measured in seconds. And this is height measured in feet. Okay. So one thing to think about, this makes a parabola if we continue it here, if we continue it here. But this is the ground, or this entire axis can be thought of as the ground, but this is where it hits the ground. It doesn't make sense that the brick would just continue with no friction or anything and just continue falling. And it also doesn't make sense in real life that we get this kind of power surge of brick that comes up and then goes through our hand and throws it down that way. So the practical domain is just everything that's represented in real life. So from when it leaves the person's hand from their balcony to when it hits the ground, that's the only thing that we would actually see with our eyes. And so domain, once again, is an x value. So our practical domain starts at 0 and it ends at 6. 3, 4, 5, 6. Okay. So practical domain is going to be from 0 to 6. Now we want to know how tall is the balcony. So the balcony is, we can reason through this in a couple ways. We can say, oh, I bet the person's about 6 feet tall, so the balcony must be 14 feet tall. Okay? Or you could say the person's 5 foot tall, and then you could say the answer is 5 feet tall for the balcony. Now, we're going to just say the height of the person is negligible, which is kind of weird to think about because 20 feet isn't that tall. So I personally would just say 20 feet tall balcony. But if you explain your answer, if you say the person was 6 feet tall, I would accept 14. If you say the person was 5 feet tall, then I would accept that. But somehow you gotta let me know that you get that the starting point is 20 feet off the ground. Okay. So what was the maximum height of the brick? So let's say this was 25 feet right here. So the very height is going to be like highest point is right there. So I'd say 25 feet was the highest point. And then when did this occur? So we're going to go down here, try to draw a straight line. Looks like it's at 2 seconds. So I would say after 2 seconds, or better yet, let's say at 2 seconds. And when did the potato hit the ground? So we just want to know the X value right here. So we say, or not the potato, sorry, I'm reading off of the one that's on your homework. The brick hit the ground at 6 seconds. The brick hit the ground. Okay. And then one more thing you need to be aware of. If you need to find the domain of this, just create a graph and do it from the graph. So you can use Desmos or you can use a graphing calculator, whatever's better for you. Since I have this graphing calculator handy, I'm going to use this. So if you need a refresher or even to be taught for the first time on how to enter these things into a calculator, you can come to Math Lab or ask me in class. Desmos is pretty straightforward, so I would probably stick to that. Alright, this one looks a little crazy. So let's see. It's hard to see exactly where that's going, but it kind of looks like it's at 1 and 2, 1 and 5 maybe. So Desmos is actually going to make it easier. So if this isn't 100% correct, I apologize, but I'm going to grade you based on your drawing. So to me, just with a quick look, there's ways we could look for sure, but I'm not going to worry about the detail on this because I want to get the concept down. But let's say that's the graph, and let's say that's correct. It goes to 1, goes to 5. So this portion is represented by negative infinity to 1, because the x values that are defined go all the way to negative infinity, and then we stop at 1. This portion is defined by 5 to infinity. And so if we're writing our domain, we take both of those pieces, we say negative infinity to 1 union 5 to infinity. And that would be the domain of f of x. If you need additional help, please come to Math Lab, but for now, calculator.